All right, PreCalc. This is day 4. These are word problems. And some of these word problems are easy and some of them are harder. If they give you the equation, which I'm pretty sure on your final, you're given the equation. You just have to be able to do it. You just got to kind of figure it out. So here's one. It's got some lengthy stuff going on here. You can read all the words. The amount of U.S. funding for Afghan security, I'm just going to kind of highlight some. So the U.S. funding is decreased during this period. So this function right here can be used to estimate the U.S. funding for security in billions of dollars. And X is the years after 2009. So the F of X is funding, and the X is how many years after 2009. So notice this is a quadratic, right? So you're thinking in your head that it opens upside down. It's going to cross the x-axis twice. I don't know where, but I'm hoping it's going to cross twice. And so you're looking for those places where it crosses the x-axis. All right, so here the funding is $10.5 billion. Now I did this one out before I made the video because there's a lot of writing and I figured it would save some time. So what I did is here's my original, right, with the function, and I set it equal to the 10.5 because that's what the funding was supposed to be. And then I subtracted it from both sides. And then I used my quadratic formula. And it was really kind of tedious just because the numbers were so small. But I ended up getting two answers for this. I ended up getting 1.7 and 2.1, which were both valid answers. So remember, these X values stood for the number of years after 2009. So when I got 1.7, I added it to 2009. I got 2010. And when I added it to 2.1 to 2009, I got 2011. So somewhere in 2010 to 2011, the end of one, the beginning of the other, is when it seemed that this was true. Okay? If you do the 5 billion, this part over here, if you do the 5 billion, then you only get one answer. So if you wanted to try that one, you could. I believe the X value is approximately 4, so it would be 2013. Okay, so now here's one that you're going to see in physics later on. You're not going to see it yet. In math class, we like to use the letter S for distance, just because of derivative stuff, and Mrs. Flanagan might talk about that. So here's my formula, S equals 16t squared, and S is distance, and it's in feet, and T is for the number of seconds it takes to fall. Okay, so this you can figure out how long you have before something hits the ground. So you're at the top of the arch in St. Louis. It's a very tall arch, 630 feet. How long does it take the object to get to the ground? Well, this is pretty straightforward because S equals 16t squared. So S, which is 630 feet, is equal to 16t squared. So you have to take your 630 and divide it by 16, and you get 39.375 is equal to t squared. Now you can take the square root of both sides, right? And that take the square root of t squared, because the square root of t squared is just t. So I take the square root of this, and technically I get plus or minus 6.27, but the minus doesn't make any sense. So it's 6.27 seconds that it takes for that whatever you're dropping, assuming it doesn't reach terminal velocity, which Ms. Flanagan may talk about. But anyway, 6.27 seconds is how long it takes to reach the ground. That's how long somebody has to get out of the way. All right, here's a harder one. You have a rectangular frame. I have this awesome picture in the inside of it. The frame is 8 inches by 10 inches, and the frame is of uniform width. So the question is, what is the width of the frame if 48 inches squared is the area of the picture? Okay, so when I was doing this one, or when I was thinking about doing this one, okay, so each of these, this is a width of W also, right? So instead of this being 10, the inside length is 10 minus 2w, right? And the inside width is going to be 8 minus 2w. Well, and that area is supposed to be 48 inches squared. So if I do area of a rectangle, length times width, I'm going to have 10 minus 2w times 8 minus 2w is equal to 48. Now, I was looking at this before I started this video. I was like, well, look at all those even numbers. So if I divide, this first bit right here, I can factor out a 2, right? And call that 5 minus w. And this bit, I could factor out another 2 and get 4 minus w equals 48. Now I can divide both sides by 4 because now the 2's cancel with the 4 and I end up with just 12, which makes the math a little bit easier, just FYI. I mean, you don't have to. Certainly you can use your calculator and all that kind of stuff, but by doing this, I distribute, I get 20 minus 5w minus 4w plus w squared is equal to 12. Here's my quadratic. So subtracting 12 from both sides and rearranging and all that kind of stuff, I get w squared minus 9w, and then 20 minus 12 is 8 equals 0. And then I'm like, oh, that's pretty cool. That'll factor, right? W equals 0. So this is minus 8 minus 1. So w either has to be 8 inches or w has to be 1 inch. Now that 1 inch doesn't make any sense in this, the 8 doesn't make any sense in this case, because if I do 8 minus 8, I'm going to end up with nothing. So I don't want that. So I want my width to be 1 inch. So my width is 1 inch all the way around. And you're like, oh, that kind of makes sense, because if this is 1 inch and this side here is 1 inch and this side is 1 inch, 10 minus 2 is 8 inches. And then 8 minus 2 is 6, and 6 times 8 is 48. I might have been able to guess that answer. You probably didn't get any of that. Anyway, rambling. Okay, quick sliding down to this one here. Okay, this is a big deal when we do these kind of problems. It happens a lot. And so let's just do this one, and then I'm going to call it a video. Maybe I'll make a second one. A model rocket is launched with an initial velocity of 150 feet per second from a height of 40 feet. The function, so here's my height of 40, right? I'm starting out at 40. So I'm going up and I'm coming back down. This is the height over here on the left, t seconds. So when does it reach its maximum height? Well, notice right here, this is my vertex, right? And we already know how to find the vertex. Remember, this line here is called the, right, axis of symmetry, AOS, axis of symmetry. So my axis of symmetry formula is x equals negative b over 2a. So I'm like, well, I can do this. Negative b, so negative 150 over 2 times negative 16. So x equals, I forget what that answer is, negative 150 divided by negative 32, and I get x equals 4.6875. So that's really my time, right? My time is that. So that's the time at which the rocket reaches its maximum height. So it reaches maximum height at 4.6875 seconds. And then how high does it actually get? Uh-oh. What happened? Where did it go? Oh, no! All right, I'm quitting.